Math is fun. Let us deal with indices, okay? Do you still remember how to label the following expression? We have this expression. Let's say I have 4x power 3 plus 5. Do you still remember that how to label this 4x 3 and 5? So we know that the 4 is a coefficient. It's a coefficient. Okay, and then we have the x is the base, which in this case is the variable as well. The 5, a number alone, is called a constant. And then the 3 is the index. Is the index or is an exponent. Exponent. Okay, so now if we have that expression, if you have this expression, you must be able to label that for the language, for us to understand that language. Okay, so now let's move on to look. We're gonna go through law of indices. When you're talking about indices, normally you're talking about this term. That term is what we deal with in indices. We deal with such terms. Okay, so we have 6 law of indices. 6 law of indices, and I want us to go in this video. I want us to go through those 6 law of indices. Okay, so number 1 is called the product law. Remember, product means times. So a product is the answer we get after we multiply. So this law goes like this. Let's say you have a to the power of m times a to the power of n. So since the base are the same, the a now, if the base are the same, the law say you can simply take 1a and add up the index. For example, if you have 2 power 3 times 2 power 4, your answer will be simply 2 power 7, which I have I have added 3 and 4. Okay, this law can also represent itself in this form, where you can have something like 2 power or maybe 3 power x times 3 power x again. Remember, the law says that if the base are the same, then you must add up the index. So it's gonna be 3 x plus x, which is 3 power 2x. Okay, so that's the first law. It's called the product law. The second one is called the quotient law. The quotient law. Quotient means division. Okay, division is it can even be called the dividing law. So how does it go now? It goes like this, that now we are talking about the division, the division law. So what you do, let's say we have again our a power m divided by a power n. So what you're gonna say is a m minus n. So if I have 2 power 4 divided by 2 power 2, then the answer will become 2. 4 minus 2, which is equal to 2 power 2 and is equal to 4. If you want to go until the number, okay. That's the second law of logarithm. It's called the division law. Let's go to the third law of logarithm. The third law of logarithm is called the power law. The power law is when you have bracket. Okay, so let's say I have perhaps 3. So I have a power m and then power n. So in this case, you can see that both the m that's inside and the n that's outside, they are all index. Power law simply means for us to remove this, we are going to multiply. So we're going to have a m times n, which is a m n. You can even just come from here to here to that one, not to waste your time. Okay, a power m n, that means we multiply it. We can also have something like this. We can also have something like this. So let's say we have a power 2 over b power 4 bracket 3. Now in this case, you can see that the 3 that's outside the bracket is applying, or let's say the bracket applied to both letter A and letter B. So in this case, that means there's 3 also applied to those. So it's just gonna multiply. So it's gonna be A 2 times 3 over B 4 times 3, which will give us A power 6 over B power 7, no 12. Okay, a lot of learners now make mistakes in this case, because what they do is that they will confuse this law, this one of multiplying the index with this one. If I have x times x, this one is different. Okay, this one means I have a x power 1 and the x power 1. Now as I'm multiplying them, they're gonna be x squared. That means I have added the index. This one goes with the first law, because bracket simply means times as well. Okay, so that is what you're doing now. Let's move on to the zero index law. So this one we simply say anything power 0, anything power 0 is equal to 1. Anything power 0 is equal to 1. Anything. Okay, so that means if I have a power 0 is equal to 1. If I have 2 a power 0, then that means it's equal to 2 times 1, which is equal to 2. Okay, let's move on to the fourth rules of indices, which is negative law index. Negative law index. So the negative law index, it goes like this. The negative law index goes like this. Let's say we have the law goes like this. So we have a power negative m. Now normally in index we do not leave our answer with a negative index. So what do? What you do here, you say, okay, it can be transformed and be written as 1 over a power m. Now you can see that I no longer have the negative, and that's what I don't want. You don't want a negative index. Okay, not the negative letter a, but a negative index is what you don't want. Now this one is reversible. Okay, reversible means this, if you find it like this, you might change it to be this way. If you find it like this way, you might change it to be what, to be this way. So that is the negative index law. Let me give you example here. Example is, let's say I have 2 power negative 4. So then from there it can be 1 over 2 power 4. I want you to notice that I wrote the 2 in big and the 4 small. Okay, which can now be 1 over 16. Okay, now what you can see is that that means this thing was also like this. Is 2 power negative 4 over 1, because every number is always over 1. Then what you're actually doing, you are bringing the 1 on top and this one down, but the sign must change. Okay, that's a negative index law. Be able to move from this one to this one and from this one to this one. Be able to do that. Yes. Okay, now and then we go to the final law of indices. The final law of indices called we are calling it fractional index law. Fractional index law. How does it work now? How does the fractional index law work? It work on this. For example, the laws is like this. Let's say we have the square, not the square, but the root of a power m, and then we have the n there. Okay, so what you're gonna do, if we don't want to write it with a root form, when you are simplifying, then you're gonna say m over n. Okay, you must understand that the n will come and divide the index that m is having. I mean a is having. Okay, let me give example on that. Let's say we have the square root of 4. No, let's say we have a square root of 16, and then the question say simplify without using a calculator. So remember, first we have to break down 16 using this format, or you can use a calculator. You can use a calculator. So what you're gonna do, you're gonna put 16 here, but this is what I don't advise you to do this. Yes, you must know this, but you must learn how to use a calculator to just go straight to the answer. Okay, so you divide by 2, then you write 8, then you ask, can 2 go to 8? Yes. How many times? You can go in 4 times. So 2 can go in. Can 2 go into 4? Yes. How many times? 2 times. So it's going in 2 times. Okay. And then 2 into 2 again. So it give you, that means 16 is 2 power 4. Okay. 2 power 4 is 16. The square root of 2 power 4. Then remember, now I said there's a inverse. If it's a square root, then there's a invisible 2 here, because in square root we don't write the what. If I write like this, automatically already there's an invisible 2 there. That's why you call the square root. So I'm gonna have 2 power 4 divided by 2, which gonna give me, but then the square root must now go away. Okay, then you can just be 2 at 2 power 4, which is gonna give me 2 power 2, which is equal to what? Is equal to 4. We all know that the square root of what? Of 16 is 4. Okay, that's on the law of index. Now in our next video we are going to look at what? We are going to look at using the law of indices to simplify, okay, different exponential problem or expression, to simplify them. Okay, so that will be doing in our next video. See you there.